Hello, everyone. Does it work? Yeah. OK, hello, everyone. My name is Igor. I work for Roche Diagnostics. I lead the strategic insight and analysis function, which also encompasses market intelligence, competitive intelligence, voice of customer, and some of this strategic decision support. And today I'm going to talk about, we hear a lot about digital transformation and the impact of digital in our business. And we're trying to look at how can we use digital in our function and the market intelligence function. So just to give you a bit of a background, I work for Roche. Those that come from the pharma part are very familiar with the company, but it's a big corporate business with 90,000 employees, offices all around the world. It's famous for that pharma branch, but there's also a diagnostic division where we do instrumentation for hospitals and laboratories. And the part that I sit in, it's part of this diagnostic division. We focus on a technology called next-generation sequencing, which is basically a way to get information out of your DNA. And there's a lot of uses for this technology that go beyond the 23andMe and Ancestry.com, et cetera. Can be used in diseases. For example, the DNA of a tumor is very different from the DNA of the host. So by looking at those differences, you can find out, OK, this treatment will be helpful for this particular patient and so forth. But also, for example, in pregnant women can get a blood test, and the DNA of the fetus can be detected. And you can look at fetus abnormality and genetic conditions before the baby is even born. Another example, it's if you look at the hereditary condition, for example, everybody knows the case of Angelina Jolie. She had 2 copies of a faulty gene that were identified through this technology, and she decided to go ahead and have a mastectomy. So these are some of the applications. But coming more to let's say the business side of things, this is what we call, I like to call the Wild Wild West in diagnostic, because it's a rapidly evolving technology. The technology is fairly new, diagnostically speaking. And so it keeps changing. The player keeps changing. There's a lot of acquisition. There's a lot of company being bought and sold, dismantled. Everybody's suing each other. There's no regulation. There's reimbursement is kind of ups and down, and it's really state dependent. And so it's kind of difficult to do market intelligence. But Roche, it's a very data-driven company. So my boss, Neil, will still want to know, OK, how big is this market? How much did it grow from last quarter? And what's our share in that market? And the vendor side, it's kind of spotty in the sense that it's not a focus for many of the vendors. And so the data is scarce. The vendors are not up to date with their understanding of the market. So we decided, OK, how are we going to crack this? And we looked at basically, can we use data from the public domain, from the digital space, to fulfill this need of information that we have. And so we looked at social media, blogs, et cetera. So I'm going to go into mentioning a few of the tools that we use. I'm going to spend a couple of minutes also looking at some of the techniques that we use for the analysis part, especially when it comes to text analytics. And then I'm going to move on to some practical example of how we use that. And so the first thing that I want to cover is this concept of API. How many of you are familiar with the term API? OK, good. So I don't need to go too much into detail. If you're not familiar, basically it's just a way to, instead of doing manually, you're interfacing with the different services like Google Maps. You can write a code that will call the Google Map engine and get the result back. And that is true not only for Google, but also for a bunch of other services. Why is that important? It's important because sometimes you're going to have fields that maybe you extracted from your CRM. Maybe you get it through a survey, et cetera, that are addresses or location that looks like this. So they're not standardized. They're text. Computer can't handle text very well. So you shoot them to Google API, and you get back something that is much more structured and much more consistent. And we will see why is that important later. And as I said, there's a plethora of services that allow you to use API and from which you can get data. So basically, everything that you can look up on a website, you can probably get it through API. If it's not there, you can still use another technique, which is called scraping. Some of you are already familiar, but basically, in its simplest form, it's you write a computer code that can go and pretend to be a user, go into a website, copy what they needed, paste it into a file, and then you have it. In terms of using the tools, so you need a special set of tools for that, and I try to mention the one that we use the most often. It goes from Excel to Tableau for visualization, SPSS for the more statistics part, SQL to handle data and mixing them and matching them and kind of transforming them. And then we use R and Python, which are these more data-centric programming languages that allow you to do a lot of these advanced analytics, including web scraping, including text analytics, including predictive modeling, and so forth. So a lot of the data that you're going to pull out of this service is text. And so one of the next steps is how do we transform text data into something that computers can handle much better? And the simplest form is simply counting words. So this is the Wikipedia article about HIV. And if I count all the words that are in this document and I simply score them, you see that actually the first one is HIV and the second one is virus. So even just a simple word count gives you a good representation of that document. Now, why is that important? Because you can then start to score documents or pieces of text into different dimensions. If you work in healthcare, unfortunately, you always have these very cheerful terms like HIV and cancer. But for example, you can take a document, plot it around this two-dimensional axis and say, OK, this one is definitely about HIV. You can take the next one and say, OK, this is about cancer. Or there might be a document that is about HIV and cancer, and so it will appear on the top right of the quadrant. Or it's about neither of those topics. And so if you do that for all your pieces of text, you end up with these groups, and then you can use algorithms to kind of do some what is called a cluster analysis, which can identify, OK, all of these are all about HIV, all of these are all about cancer. And then you can look at where the center of that cluster is, and you can start to say, OK, all these documents are all about these terms, right? The most common terms among all of them. Now, this is very simple if you do in a two-dimension, but computer, thanks to, let's say, their nature, they can do it across infinite number of dimensions. So you can actually take each word as a dimension and do the same exercise, and you can basically turn a bunch of text into a bunch of topics. So without knowing anything about that text, you can extract topics in a completely unbiased way. So there's no hypothesis, it's simply what the data tells you. And that's something that it's very useful, and we'll see why. The other things you can do, you can take all this text and say, OK, now I'll take all the words that appear across all of them, and I put them into a matrix. That is what they call the document term matrix. And you can then look at, OK, how often term 1 appears with term 2 across all my documents. And you calculate those correlation factor. And you can turn that into a network, where each node is basically a term, and each link represents the strength of the connection of these terms. And so you can create a visualization where things that appear often together will end up clustered with one another. OK, so why do we need all of this? And so I'm going to go through some example of things that we have implemented. The first one was we have a bunch of conferences that we tend to attend. Budget gets tighter. We cannot go to all those conferences. And so we decided for those conferences where we don't go, can we use social media to monitor what is happening in that particular event? And so conferences are great because they are based on hashtag. Very often a conference will have a hashtag, and so you can narrow down to just that one conference, and you're going to be sure that whatever comes from social media related to that hashtag, it's very likely to come from someone that is actually at that conference. And so I'll give you an example of a conference that happened early this year in Orlando. We selected a bunch of hashtags. We have a Python script to query the Twitter API. We process it with R, and then we visualize it with Tableau. And we got a sizable data set for a conference. There were 12,000 tweets for a 3-day event, 1,200 users, so you can start to make some inferences. And the first thing that we did is, like, can we look at people that are influential in the digital space, that are leading the conversation, that are shaping that conversation? And so we calculated a bunch of scores. One is how often do they tweet and how popular each tweet is, and how often the cumulative sum of all their tweets are. And we end up with basically two types of influencers. Those that influence by reach. So those are people that talk a lot, and they get retweeted a bit for each tweet, versus people that tweet less, but they get a high level of retweet for each tweet. And so this allows us to identify those influencers, which you can then engage either online or offline. For example, you can get them to cover your next session or your next event. The other thing we did text analytic using that clustering technology that we, or methodology that we mentioned early on, and we could look at the topics that were discussed. But also we could look at how different competitors are covering those topics in their tweets. And we could look at the mix, their marketing mix, and also if we use the same scoring that we did for the user, we can say, okay, how effective were they? And was that correlated with how their marketing mix looked like? A couple of words of caution. Not all conferences are digital. Some of them are more digital than others. There's some bias in terms of the user. You're going to have an overrepresentation of maybe the younger crowd compared to the older crowd. So it's something to keep in mind. Whenever you explore those things, it's useful to have some skeptics tell you, hey, I was there, and that's complete BS. The next example is around mining specialized blogs for competitive intelligence. So we work in this space of next generation sequencing, and one of the key things is having an instrument. And so we found a blog that is specializing in this space. It's called CiCancer. And the good thing about this blog was that there were 40,000 profiles that were active last year. And each of these profiles had two things, had a location and had which instrument they have in-house. So that gave us, okay, that's a great starting point for starting to see who has what. And so if you notice, for example, the location is in that format that it's kind of a free text. So we pass that to the geocoding API, as I was mentioning early on. We get a very, very kind of a cleaned out version of that. We use some tagging to identify the instrument, and we were able to identify distribution of instruments across the different countries and geographies. But we were also able to identify which instruments are bought together. So if I'm a customer and I have this instrument, I'm likely to also have this other instrument, or what is mutually exclusive. Again, couple of words of caution for that. It's this is self-reporting. It's based on self-reporting. Self-reporting is inherently biased. We have also an overrepresentation of English-speaking country because it's an English-speaking blog. Also, people, when they sign up, they will fill out the information, but if they change their instrument, they are unlikely to go and update the profile. So it's good to think about, okay, how biased is my data towards certain factor? And also, multiple users might be sharing the same instrument. So just because I see 20,000 people using that one type of instrument in Boston, it doesn't mean that there's 20,000 instruments. And the last example that I want to bring is really about the competitor space. So we had this idea of, can we look at where our competitors are going by looking at what they're hiring for? So development cycle in the diagnostic industry are fairly long. So you start developing a product, and then 5 years down the line, you got something that it's tangible, and then 2 years later is registered by the FDA. So you're looking at 5 to 10 years between when you start a project to when you actually commercialize that product. But in the meantime, especially if it's a new area, you start to hire skills and things that are maybe specific to that one product type. And so the other thing is everybody hire, and job listings are public domain, and they can contain some clues. So we said, can we look at this unstructured data and figure out if we can pick up some clues? And so we develop a pipeline where we scrape those job listings using Python, do text analytics, same thing as before. But this time we start from the competitors' job listing. We also pulled in data from Indeed, which is like this job listing portal, because we also wanted to suppress the noise. So we look at job description from all other industries, and then we take all those words that are common across other industries and remove them. Leadership, cross-functional team, collaboration. Those things are not really relevant. But so we needed to remove, and what's left, it's what is actually meaningful. And so we created this network visualization using that analysis that I showed early on. And the way we decided to show it, it's through a map that our stakeholder can navigate, and they can go and look at cluster of terms that end up being together. And sometimes they're representative of a technology effort or maybe a structural change, and so forth. And also, as they click on each of these nodes, it'll tell you basically which kind of position they are, where are they hiring from, and what are the other common words that appear there. And that also allows us to identify center of excellence. So for example, we were able to uncover that certain things happen across the US, but then there's a center of excellence for a particular domain in the UK, and then the manufacturing is done in Japan, etc. So that gives us some clue about the competitor. And the beauty of it is that we now have like this running as a service. And so on a regular basis, we get new jobs in, and then we can also track it longitudinally. Again, some limitation, not all jobs are posted. So especially the more executive and senior level position are maybe like, let's say, less likely to be posted and more hired internally. Also, if the job is if it's an internal effort where people, especially at the beginning, they tend to hire from a cohort of internal candidates, you're not going to be able to pick it up. Scraping might not be allowed in certain situations, so always make sure that you check the term and condition, but the general rule is if it's on Google, you can scrape it because it's basically indexed. The other thing, its results tend to have a margin of error. So rather than give a definitive result, we decided that it's more useful to present the result to our stakeholders, and they can make their own conclusion. So we just give them a platform to explore conclusions. And human review, it's always helpful to kind of contextualize things. So to close, I only kind of, I want to kind of spend a couple of minutes talking about how we bring all this together. In our function, we also have market research function, and we do the classic CI, the traditional market intelligence, traditional competitive intelligence. And I strongly believe that these digital technologies are complementary to that. I think it's not a replacement. It's actually how can they work with one another to give you a good results. And so it's important to understand the bias that you have in each methodology and how can they complement each other. For example, when we did that scraping of blogs, we knew that we were oversampling for English-speaking countries. So when we went to do the market research, we also kind of boosted a bit the number of the non-English-speaking countries. Just some tangible example. And also, another thing that we found useful, it's, as I said, bring the skeptics on board. They're going to help you to see blind spot that you didn't think about or why that is not applicable. And also, another thing that is very helpful is to experiment with things that you know. If you want to run your own pilot with these kind of things, take something that you know well, see what the results come out, and see why it's different from what you would expect. And so that then you can understand the bias of your process and start to put guardrails around it. And finally, I wanted to thank my team, which is, some of them are here in the room as well with me. And they actually do most of the work. All right. Thank you.